Good morning. Sorry I'm out today, but it is an easy day, so you got this. Today we're doing solving quadratic inequalities algebraically and solving quadratic inequalities by graphing. So when you look at the notes, this is solving quadratic inequalities one variable, because if you look at your equation, you only have one variable. But when you graph, you have two variables, an x and a y. So just keep that in mind. So solving quadratic inequalities, one variable, here are your steps. Write in standard form. So make sure you're putting it in ax squared plus bx plus c form. Change the inequality sign to an equal sign for now. Solve it, graph the solutions, test 3 points in each section. So let's get to that part. Standard form, ax squared plus bx plus c is greater than 0. That's the new part. So we're going to solve it. When you solve it, we had a test on solving it. You can factor. You can use your quadratic formula. You can use completing the square. And you can use, I'm missing some, square root. Remember, not all methods work every time. But with quadratic inequalities, most of the time they can factor. If you're really against factoring, you can use the quadratic formula every time. It's up to you. But those are all your methods of solving. So set a equal to 0. This is factorable because I know numbers that multiply to negative 12 and add to 1. Factoring is the quickest. That's why I know you guys hate factoring, but if it's factorable, it is the quickest way to do it. That would be 4 and 3, and we need the smaller number to be negative or the bigger number to be positive to add to a positive. So plus 4 plus 3. So x plus 4 equals 0, x plus 3 equals 0, x equals negative 4, x equals negative 3. Nope, I did some signs wrong. It was a negative 3. So that'd be negative, so that'd be positive. Negative 3. Yep, that looks better. Okay. So at negative 4, we're going to come down here, and we're going to put an open circle, because remember, inequalities, this is greater than. So when we graph it, if it's greater than or less than, it has an open circle. If it's greater than or equal to or less than or equal to, then you'll have a closed circle at these solutions. And then 3, again, open. And then it tests 3 points. So these two solutions broke our graph into 3 different parts. So I want to choose a point from here, I want to choose a point from here, and I want to choose a point from here. And we're going to plug them in, test areas. So on this one, I'm going to plug in x equals 0. That's the easiest number to plug in. 0, 0, negative 12. Negative 12 is greater than 0. If it's true, we shade there. If it's not, we shade in the other areas. So negative 12 is greater than 0. No, it's less than. So we're not shading here, not shading in the middle. We can try negative 7 just to make sure we're shading on the outside, but you're either going to shade on the inside or the outside. So since we're not shading on the inside, you're probably going to shade on the outside. So we're going to plug negative 7 in. Okay, so when I plug negative 7 into the calculator, I get 54. So I plugged in negative 7. I got out 54 on the right. Is 54 greater than 0? Yes. So you're going to color in this whole side of the number line. So any of these numbers to the left of negative 4 will work. If you plug it into the calculator, this calculator also has greater than or equal to signs. If you do control equal to, greater than 0, it'll tell you if it's true or false. And then just to check, you can do a positive 7. That'll be easy. Is also true. If you did plug in one of your endpoints, or I'm sorry, one of your solutions, like we got 3 as a solution and we had 4 as a solution, it's minus 12. All of these answers are wrong because it's minus 12. Man. If you plugged in one of your answers, it will give you a false statement, which is why it's an open circle. Just so you know. Just make sure. Minus 12. There you go. True. So I know they work. So we're shading on the outside of our graph. I think odds I'm going to do factoring, evens I'm going to do quadratic formula. So let's do another factoring one. Standard form. First step, put everything in standard form. Add over your 26x plus 84. Change it to an equal sign. If it's factorable, factor. Well, it's a greatest common factor of 2, so I'm going to factor that out. Make my numbers smaller. $42. Anything multiply to 42 and add to 13? 6 and 7 does. So we have x plus 6, x plus 7. Solve using factoring, add, set each parentheses equal to 0 and solve. X equals negative 6, x equals negative 7. Plot those. This one, again, is just greater than, so they'll be open at these plots. Look how close it is together. And then so to test a point in the middle, it's going to have to be a fraction or a decimal. Negative 6.5. That's what I'll plug in. Negative 6.5. When I plug my answers in, I don't plug into standard form. I always go back to the original equation. So if I somehow messed up doing the original, like changing it to standard form, I know my solutions are right anyway. So I'm going to plug in negative 7, and I'm going to plug in, negative 6.5. You can plug in your test solutions if you want to make sure that it's not true. Okay. I think I got it all right this time. It is false on the inside, so it should be true on the outside. Remember, you can scroll up and highlight it and hit enter to copy and paste it and just change all your negative 6 to another test area. So I'm going to say 0 is on the right, so we'll try 0. That's true. So it looks like we're shading on the outside. It does not take long to test points in this calculator. In a scientific calculator, it takes some time, but in this calculator, it doesn't. We can try negative 8 for the other side. Make sure when you're squaring a negative number, you put it in parentheses. Oh, crud. Sure. So it is shaded on the outside. Okay. All right. One more factoring. Is I really want to factor one like this. You can use factoring on all these, or you can use quadratic formula, or you can use completing square. I know how much you guys loved completing the square. All right, remember, there's no greatest common factor, so you have to do 2 times negative 5. So negative 10 and 3. When there is an a in front of your x squared, you put that back in the front. So we have an extra factor of 2 that we're going to have to scale out later. That'd be 5 and 2 have a difference of 3. We want to add to a positive, so you want the bigger number to be positive. So plus 5 minus 2. I have to take that extra factor of 2 out. So I don't really want to take it out of a 5, so I'm going to take it out of this one. So 2x plus 5 and x minus 1. There is your factored form. You can always check it. You can go backwards, make sure it equals. Set both of them equal to 0 and solve, obviously. So we have 1. Now it's greater than or equal to, so now we have a closed dot. If I plug 1 in, I would get a true statement. 2 plus 3 is 5. 5 is greater than or equal to 5. Negative 5/2 on the graph is negative 2.5. So just halfway in between negative 2 and negative 3. Check 0. 0 plus 0 is greater than or equal to 5. False. So I'm going to shade on the outside. These graphs are usually shaded on the inside or on the outside. So if you check all 3 spots and like one of them is true, you might have, and it's like 2 true here and here, then you probably did your zeros wrong. So we go back and check our x-intercepts, our zeros, our solutions of these equations. You can plug it in if you want to check it. Let's do a quadratic formula one, because I know you guys like quadratic formula. I think factoring are the quickest on these. It's weird putting 0 first, but everything's already on that side. We're going to switch it to an equal to anyway. So quadratic formula. A equals 1, B equals negative 10, C equals negative 16. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. X equals 10 plus or minus the square root, positive 10 because I had to change my signs. 10 squared minus 4 times 1 times negative 16 all over 2 times 1. Okay, simplify under the radical. 10 squared minus 4 times 1, I don't have to write, times negative 16 is 164. Square root of 164 is 12. Oh, guess what? It's a positive 16 because I had to move the 16 over. Positive 16. Try that again. Might have been quicker for me just to type it again, but I didn't. 36. So the square root of 36 is 6. Oh no, I typed that in the calculator. So I have x equals 10 plus 6 over 2, and x equals 10 minus 6 over 2. So 16 divided by 2 is 8. 4 divided by 2 is 2. So one's at 8. Come back here, close dot, and one's at 2. And test a point. 0 is now on the outside. So if I test 0, is negative 16 greater than or equal to 0? No.